What is the sun made of? Hello everyone! In today's video, we're going to tell you about the dominant object of the solar system that's brighter, more massive, and more influential than anything else – the sun. Let's find out what the sun actually is. Nowadays, we know that the Earth and all the planets rotate around the sun, but it wasn't all that long ago that people believed that Earth was the center of all things, and that everything rotated around us. It holds 99.8% of the solar system's mass. The sun is one of more than 100 billion stars in the Milky Way. The sun is a very hot ball of mostly hydrogen gas. It's basically a nuclear furnace, burning hydrogen fuel to make heat and light, and driving everything that happens, not just on Earth, but also throughout the solar system. Without the energy coming from the sun, nothing would work, and everything would be dead and lifeless. This huge ball, 869,000 miles across, keeps everything alive. You can fit more than 1 million Earths inside of it. The core. There's no solid surface inside the sun. In the inner core, nuclear fusion takes place, generating temperatures up to a searing 15 million degrees Celsius. The conditions here are hellish. The pressure is 260 billion times the Earth's atmospheric pressure. Here, hydrogen atoms fuse together and get converted into a heavier element, helium, and massive amounts of energy are released. It's equivalent to detonating 400 billion 1-megaton nuclear bombs every second. These reactions make the core look like an extremely hot mix of subatomic particles, also known as plasma. Such energy heats the gas above the core. The radiative zone and convective zone. The core is surrounded by other, much cooler layers, and the energy generated in the core is transported through these cooler layers to the surface. Energy from the core is transported outwards directly by the radiation itself, hence the name radiative zone. The gas becomes less dense. Huge amounts of rising gas from the core make up the convective zone. Convection currents carry the energy outward to the surface. Photosphere. This layer of the sun has a relatively cool temperature of only 6,000 degrees Celsius. Quite chilly, really. The density of the sun's material becomes thin enough to look almost transparent. Photosphere is pretty thin, only 300 miles. And this is the light that we see when we look at the sun, although we can barely do it even in sunglasses. Because of the distance from the sun to Earth, light reaches our planet in about 8 minutes. Corona. Corona lies above the photosphere and is considered to be the upper layer of the sun's surface. It extends to millions of miles. It's only 1% as dense as the photosphere, but the temperature here is over 2 million degrees Celsius. Why the corona is up to 300 times hotter than the photosphere, despite being farther from the solar core, has remained a long-term mystery. Now, you can't see the corona with a naked eye due to the fact that it's too thin. Only special coronagraph telescopes can show its beauty, and corona gets its name from the crown-like appearance that's evident during a total solar eclipse. Solar prominences. Now, sometimes the magnetic field emerges from the lower regions and loops back down into the sun. These magnetic structures can be seen extending up into the corona. As particles follow the path, they form dynamic loops and arches. A rogue flare could damage electrical grids or knock out our communication satellites, as has happened many times before. The strongest category of the outburst, called an X-class solar flare, could cause havoc if it reaches Earth. On Earth, we are completely protected from the direct effects of solar activity. The atmosphere shields us from the electromagnetic radiation from solar flares and the particles in a particle storm. Solar wind. However, the corona isn't the end. It merges into the solar winds, also known as the streams of particles moving away from the sun into space. The speed of the wind is more than 622,000 miles per hour. And as the wind travels off the sun, it carries charged particles and magnetic clouds. Emitted in all directions, some of the solar wind is constantly buffering our planet, with interesting effects like the aurora borealis in the upper atmosphere. The sun's fiery nature, tremendous gravity pull, and powerful magnetic field make it the heart of the solar system. Leave a thumbs up if you like this video. Don't be indifferent, share this video with your friends, and write your ideas in the comments below.